I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends, and we'll build it with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Mukund Karanjikar, CEO CleanJoule. On today's episode, we'll discuss the current state of the aviation fuel market and how we can decrease the aerospace industry's reliance on fossil fuels. We hope you enjoy this episode. Mukund, welcome to the podcast.
Thank you. Great to be here.
It's great to have you here. You have an encyclopedic knowledge on the history of aviation as it relates to fuels, which is absolutely fascinating. From 1905 to 1959, gasoline, and then 1959, the Jet A standard was starting to be developed. We're currently running on Jet A today and Jet A1 today. What's the current state of the aviation fuel market?
So currently, aviation, as you know, touches almost all lives on the planet in almost every single country. It is as a part of modern society, modern civilization. It's as integrated as us breathing or drinking or eating, right? So when you put numbers to it, it's very staggering. So you have a market size of 100 billion gallons of liquid fuels. So Jet A, Jet A1, essentially same hydrocarbon, a fuel that flies plane. That is 100 billion gallons today. The projections are, and I think we as a civilization have done fantastic in bringing people out of poverty in swaths. One sign of have you come out of poverty is have you taken your first flight, right? And United Nations has done fantastic. The projections are by 2050, at the low end, you will have a demand of 160 billion gallons of fuel annually sold, bought, to 210 billion gallons, depending on how things go between here and there, obviously. So the industry has done fantastic job of making it part of the modern society in order to grow that market by that size. And if you know, for rest of the world, gallon is 4 liters, roughly it's 3.8. So it's 100 gallons would be 400 billion liters, one way for you to look at it. And 210 would be 800 plus in billion liters. That's massive volume for one small, cohesive, monolithic industry.
The spread between 160 billion gallons and 210 billion gallons is it's a 50 billion gallon spread. Are those projections based on global economic growth, and depending on where global economic growth, and that will determine where we end up on that projection?
That's exactly correct, Grayson. I think the if you were to divide the OECD world, right? So the economically developed countries and the developing nations / emerging markets, most of the growth in aviation, where number of airplanes being sold, that's going to be a lot more in emerging markets than it's going to be in developed markets. And emerging markets have a big spread. I mean, some countries are growing 10% plus and others are 4% plus. And so you are absolutely right. It is based on their own growth trajectory as being considered by the United Nations.
As China slows down, India's growth is growing at a breakneck speed. It's becoming a very industrialized, commercialized market. And I'm not going to get projection on when growth ends, but the growth will go on for a long time. Are you seeing jet fuel growth in the Indian market?
Absolutely. Staggering, actually. More than double digits, literally. Because if you just, and this is recorded on the internet, if you look at the aeroplanes that are on order by the airline operators in India, those are massive, massive numbers.
Which is healthy. Then you started the company in 2009. A lot's changed. We can look at the history books, or a lot's changed since 2009. But what have you seen specifically in the aviation fuel markets that's really, really changed?
Yeah, I think I would say familiarity with the challenge is the biggest change, Grayson. So back in 2009, it was no less urgent to solve this problem. But all of a sudden, if you take an average newspaper from 2009 and take an average newspaper, and I say newspaper because, I come from the era where there used to be actually papers that you read. News releases, regardless of the medium of news release. If you compare the two, both climate as well as how hard it is to decarbonize aviation is a lot more apparent to a lot more people. And the world grew at a staggering pace between those 2 years. So for me, my urgency as an engineer was the same in 2009 as it is now, because we are solution driven as applicable to a marketplace that is only growing with very few alternatives. But the societal narrative has shifted with a lot more people having familiarity with the urgency of the challenge on one end, and adopting the conference of parties framework by governing parties around the world, regardless of who is in charge in any given country, understood to be conference of parties being the various countries, that all of us have a collective responsibility to save the planet from climate change related challenges. Decarbonization has become a common word being used by everybody because of those two massive movements, more on the side of public opinion, public narrative, than those among us who have been on that journey. It remains the same for us.
Yeah, it's definitely changed over that time. SAF, which is commonly known as Sustainable Aviation Fuel, has really started to enter the market. How large is the market for SAF now?
If you ask me as an entrepreneur who is out there to disrupt Jet A, I would say it's the size of Jet A market. If you ask me how much is being sold, that is very little. I mean, you're talking about 150 million gallons with an M, whereas the current market size is 100 billion gallons with a B, right? So last year's number, the actual data on the internet says, and which I agree with, is about 600 million liters, so 150 million gallons, which was double of 2022, which was only 75 million gallons. So if you look at it, this has to multiply at this rate to get to anything meaningful. So market size is the full Jet A. The market penetration is absolutely abysmal at under 1% if we give sort of aggressive estimations to the whole industry.
So we're at 100 to 150 million gallons today annually. How do you see that growing over the next 5 to 10 years?
There are a lot of projects being announced, including CleanJoule's own journey. Will it grow adequate by 2030? I don't think it will. I think the urgency then in the decade starting 2030 is going to be just that much more. I was going to give you a cricket metaphor, but I understand your audience may not be. Bottom of ninth, all bases loaded, that type of situation in the 2030s is kind of extremely urgent. But I'll tell you where the industry is lacking. I think the industry could use more investments. This is not a winner take it all market. If it is, we hope it is CleanJoule, and we will be. However, the market is so large, there will be more than us successful players. By 2030, if you take addition of all the projects that have been announced, even if all of those actually produce, we will not meet the target that the globe has set up, because 2050 is net zero for aviation as called out by IATA, and they are the association of almost all the airlines around the world. NBAA, which is the second association of private aviation aeroplane owning entities, if it's people, business houses, corporate houses, leasers, whoever, they also have the same target. And if we don't multiply the investment almost logarithmically in this field, we are going to miss both the targets.
How many companies today currently manufacture Jet A? Is it very similar to the Seven Sisters in oil, or what does that look like?
Oh, there are only a couple of sisters in this case, and it's equally slow. It's unfortunate. So there is only one known pathway that actually makes anything commercially today. It's called HEFA. It stands for the engineers among us, hydrogenated esters and fatty acids, which basically means let's collect the used cooking oil, the throw away lipids that people don't like. You do palm oil refining, some lipids get thrown away. Those are useless for putting into soaps and shampoos. Beef tallow, sort of animal products industry has these fats that are their side products. Tall oil comes from pulp and paper. So anything oily that you would fry your tempura in, that used or throwaway material that is converted into Jet A blendable fractions. And it's only permitted to be blended up to 50%. There are only 2 or 3 players around the world who actually make any meaningful quantities. And we are going to, and that's still just from one pathway. We are going to need a lot more people from a lot more pathways.
This raises the question because California recently announced airlines flying into and out of California will look to increase the amount of sustainable aviation fuel, SAF, they use by 2035. The question is there even enough SAF supply currently in the market to support this publicly stated goal?
There isn't, but I'll tell you the relevance of such an announcement. It shows directionality from governance perspective that yes, we the policymakers, we the governors slash presidents slash mayors, we understand the urgency and we are going to help the industry get a bit of tailwind. If you look at European nations, for that matter, EU or United Kingdom, their signaling is even a lot more aggressive, both on the pricing guarantees the governments in the EU as well as UK are telling you, and certain mandates that they have put. So, to give you an example, they eliminated tankering provisions. What will happen is a lot of Middle Eastern flyers who come into Europe, they will carry their own fuel for both sides because it's extremely cheap over there. We know that. They will never fill up in Europe, but it is important for them to eliminate the tankering provision so that now they are forced to fuel up in Europe with a blend of SAF as a mandate. Otherwise, KLMs and Lufthansa's of the world, I'm using the name, do not have any business relationships with any of them. We have business relationships with 3 other airlines, which are far more efficient and cost effective to fly. But I'm using those names because they are popular. The tankering done by an average Middle Eastern carrier would put the airlines that operate out of Europe at a disadvantage on fuel costs. So now not only you get a fuel cost parity, but you also get blends of SAF in Jet A as additional signaling by the policymakers that we are there to support the industry. California signaling is no different. There isn't, to your question, just to be clear, there isn't sufficient fuel. However, there is signaling that could be used by producers to raise money to set up manufacturing plants to produce in the following years.
How is SAF traditionally manufactured? Are there any headwinds that could further slow down the adoption just from a supply chain perspective?
Yes and yes. I mean, there are general headwinds because, to give you an example, all the approved pathways, even though I told you HEFA is the only pathway that manufactures anything, there are 2 other approved pathways. There are 7 total, but 2 others have 50% blend approval. All of them are limited to 50% blendability. So they can never penetrate beyond 50 mathematically. Forget about physicochemically. Can you actually decarbonize? And you cannot, right? You have to go net zero by 2050. IATA says we are going to need 65% contribution from use of SAF. How do you do that with only 50% blend, right? So that's the first headwind towards decarbonization. The industry adoption headwinds are in petroleum is extremely energy dense, and you drill a hole in ground, it produces for quite some time and fills up a lot of tankers slash pipelines. It's an industry that has matured since 1859, right? So you go 1859, Colonel Drake, was not saying drill, baby, drill, but happened to drill because he saw outcrop of kerosene by the side of the rock. That's why kerosene rock liquids. And 1859 to now, it has become extremely efficient. Incumbency is very strong, so the headwinds feel that much stronger. They have optimized it down to 1 cent per gallon. The feedstock challenge that you referred to is a big one. aggregation, siting of these manufacturing plants, permitting of the manufacturing plants. The manufacturing has to be done as close to feedstock as you can to derive certain economics of scale. Where are the airports located relative to where this is manufactured? All of these are prevailing questions on an ecosystem basis. So I, as an entrepreneur, I can break my head over the wall all day long on I have the most cost effective manufacturing process to produce 100% SAF. We want this to develop as an ecosystem.
You need the ecosystem. Then you have partners. Then when you have partners, and you have a supply chain. Then we have supply chain. Then you have investors, and it all just works, and it's beautiful. You're taking a different approach than the traditional model of making SAF. What's your approach, and what does your process unlock?
As you know, the journey goes back to 2009 when I was a recovering chemical engineer. I worked in oil and gas before that. In 2009, I asked myself, how can I be societally relevant? Because drill, baby, drill is extremely efficient and I have zero value addition I can offer. Decarbonization is kind of at the heart of it, right? And then the next question is, what are some of the hardest to decarbonize? And aviation rises literally to the top. And then you ask yourself, okay, so what? Then let's peel the onion another layer, and how can you make the difference? So our journey from the very beginning was we understood the 50% blendability limit because we looked at physicochemical structures of molecules. We did not look at it from a financier's perspective. We did not look at it from an airline's perspective. We looked at it from an engineering perspective, is how do the molecules actually look like and why 50%? It was a very basic question that led us on this journey of, oh, I see, if you make these materials called cycloparaffinic, they call it kerosenes, but alternative materials are not in kerosenes. There is no kero, no rock. We make cycloparaffinic hydrocarbons. They have the highest density, which is your first primary character of being able to hit that 100% mark, that you don't need to be blended. So we started on the journey all the way there for full performance Jet A like hydrocarbons that do not need to be blended with Jet A. So that was first key distinction in our mind. Let's make something superior. You are making your life miserable. Anyways, you're going to run a marathon, might as well jump into that pond and make it a triathlon, right? So we have this massive challenge in front of us. Okay, let's make something superior. So that was kind of first driving force from our viewpoint. The second one was the ability to make something from something else rests on total efficiency of the manufacturing process. It's not rocket science. How do you put as little as you can and get as maximum as you can without violating Newton and Einstein's laws? And that's basically the whole enterprise. Is carbon efficiency of molecular transformation was another driving major force for us. Is let's get highest possible carbon efficiency with least amount of exogenous energy or material input, and we optimized it on that molecular transformation paradigm for then producing superior hydrocarbons that have ability to replace, supplant the entire Jet A from your tank. And those are two fundamental differences, Grace. And the third one is we have what we call in our lingo feedstock flexibility, because that's what you are going to need. Even petroleum crude, if you build a refinery for Venezuelan crude, you cannot put Libyan crude in it and vice versa. It just doesn't happen. And so now the burden again, Jet A has to solve everybody's problem. So we have to build feedstock flexible manufacturing process. So we have built feedstock flexible manufacturing process. It can use your Venezuelan crude equivalent, so let's call it corn residue, to Libyan crude equivalent, to let's call it, forestry residue, and everything in between that on the feedstock flexibility paradigm. So feedstock flexibility high carbon efficiency, therefore economically very attractive, and making superior hydrocarbons that solve the 100% SAF adoption problem.
Well, you have the heavy crude, you have the light sweet crude, and different refining process. If you didn't have the chemical engineering background that you have in oil and gas, would you have been able to found CleanJoule and get to where you are today?
No, but I made the choice of being a chemical engineer. So I'm kidding. I'm kidding. I'm proud of my profession as my academic training, because I'm connecting the dots in the past. This does not, as I said, I use rocket science on purpose because it's kind of high level of science. This really doesn't take rocket science. I think it's about sitting around and asking those hard questions. I think that the issue with the world of 140 characters and doom scrolling is attention span. I mean, you these things need years, not minutes, hours, days. I mean, you people ask me, my investors, what's next quarter? I'm like, you know what? Do not come to me with a unit of time that is less than a year, because I have no answers for you. The least count on my clock is years. And most people have to do that, have that degree of patience in order to solve these problems. It does not need the depth of engineering or science that you have. It's an add-on. It's easier to have the perception. But most successful people who have done world of difference in science and engineering were not scientists and engineers. They just had the grit and resolve to think through and find the right problems to work on.
When did you start to think, what is possible? How can I truly build SAF in a different way? When did you start to think that through?
That was between 2009 and 2012. So what happened was the US Navy came out with a solicitation, for the lack of better words. It was an opportunity to partner with the US Navy on the Great Green Fleet. If you remember, back in days, Navy was very active, and they still are. I think US DoD plays a pivotal role both as a buyer of material, but also developer of ecosystems of alternatives, so that we have the energy security, the national security, the domestic manufacturing that we need as a society to have that power projection so that wars never happen. So US Navy 2012 had the solicitation, we need full performance. I'm like, yeah, that's me. Okay, so 3 years of work goes into that, responding to that one solicitation. And when they chose us for the award, which was a contract that followed multi-year journey then, with several US federal contracts and private funding to go along, in 2012, I knew we are on to something that is going to be everlasting.
The Navy has one key metric that all DoD has: performance and reliability. That's the big question. When you're in combat or you're in theater, you must have reliability and have performance. What impact does SAF have on performance? Does it unlock anything? Does it increase reliability? What impact does it have from that perspective?
Our SAF, particularly CleanJoule's CycloSAF, enhances the performance, and I'll tell you how. The other SAFs that, if and when produced or are being produced, they are just a drop-in blend. They give you assurance of availability. We give you assurance of availability as well as, remember I said we are on a path to 100% SAF, therefore we produce cycloalkanes. Our cycloalkanes are higher density, which gives it a superior physicochemical characteristics. That leads directly to 10% higher megajoules in the same gallon. All fighter jets fly full tank. Now you know what happens to the range. We also have, because they are cycloparaffinic, they are thermally more stable than most other hydrocarbons. Therefore, if you throttle your plane and pass that Mach 1 barrier, you're going to get super hot. When you have thermally stable stuff in there, that helps. That's the second character. Third one, we let them fly further higher in air because the temperatures get very, very low. Our freeze point characteristics are also superior than other SAFs and Jet A, which means you're not going to have honey powering your aeroplanes in terms of its viscosity. You're going to have liquids that flow like liquids up in the air at 60,000, 75,000 feet. You can go stealth, do not go stealth. None of these things matter. And the last one is This study was done at the Air Force Research Labs in Dayton, Ohio, at the Wright-Patterson Air Force Base. They demonstrated in a combustor up to 86% reduction in contrails formation by demonstrating and measuring 86% reduction in particulate matter formation, because they are directly correlatable. What you measure is particulates, but you reduce particulate emission by 86%, your contrails also get reduced by 86%. Another important factor for the US government, like contrails are the best way to find where the plane was and where it's going, because you have this white line behind it. So you could have a stealth aircraft and you could still have contrails, and you're like, oops, it's right here. And so not having contrails is an important aspect as well, and we enable that. So those are 3 or 4 performance enhancement, Grayson. I mean, to your point, performance enhancement is at the top of their list. You are absolutely right. Then ability to produce it on a schedule and when they want it and where they want it. So we top that ladder of superiority of hydrocarbons.
So you're giving more range, you're giving increased security. There's a lot of national security reasons why the Navy and all the armed forces, as a matter of fact, would want to go with the CleanJoule SAF. From a pricing perspective, how does the CleanJoule SAF compare to Jet A fuel?
So we don't have a full-scale commercial manufacturing plant, so I'm not going to talk about today. That's the beauty of being an engineer. You always get to talk about tomorrow. So at commercial scale, we will be cost competitive with as Jet A priced.
Okay, so if you're cost competitive and then you have national security issues, there's a lot of really positive there. Then the Navy, they're known for this. All aircrafts need maintenance. I want to go on a plane that's been maintained. I don't want to go on a plane that the individual hasn't kicked the tires on, no pun intended. From a maintenance perspective, because if you went, not good. From a maintenance perspective, what impact does SAF have on the aircraft engines?
So I'll talk about our SAF in particular, because I have not seen the actual combustion characteristics of other SAFs. I'll tell you ours. So we have 3 different airlines as our investor. They are not only equity investors, but we also have offtake agreements with them. Frontier in the United States, Wizz in Europe, and Volaris, they are headquartered in Mexico City. All of these are low-cost carriers. They have advanced the art of innovation like you can't believe. The efficiency with which they operate, the new fleets that they have. And when they looked at our hydrocarbon fuels with 86% reduction in particulate matter formation, as demonstrated in a combustor. This is not evaluation in some laboratory calorimeter. This is combustor, which is a replica of a jet engine done by the Air Force of United States. All of them stood up in their chairs and they're like, how can we have more of this? Because engine maintenance is the single largest expense other than buying fuel for any airline, all the way up to private aviation owners. And the single largest reason to have engine overhauls is coke/particulate matter formation inside the engine on various surfaces. You have to take it out, you have to clean it up, put it all back together, and away you go as flying. So to your point, if you reduce particulate matter/coke formation by 86%, let's say hypothetically, I don't know this number exactly, I can find it out for you, but I'm sure a lot of your audience know, probably 6 to 12 years would be my guess to have an engine come under maintenance cycle. Imagine that goes 25 years. Now you have avoided 3 different maintenance cycles, and you could do that if you have 85% reduction in carbon particulate formation. So our SAF particularly burns extremely cleaner, Grayson, compared to Jet A. And this is head-to-head data measured by the Air Force Research Lab. They burned Jet A and burnt our stuff, and 86% reduction.
For your fuel, does the fueling infrastructure have to change at all, or can you use the existing infrastructure that's currently available on runways and bases around the world?
No, it has always been fully drop-in, and it will remain to be so. If I had written anything non-drop-in back in 2012, you and I won't be talking about SAF today. The Navy would shoot me out of the room.
That would hurt. We don't want you to get shot. How about I'm going to stay on infrastructure because I'm curious. I don't want you to get shot. From a storage perspective, same storage or do you have to use a new type of storage?
No, same storage, same pipelines, same fueling infrastructure. So sort of these little tanks behind the trucks you see that they get filled up at the storage tank outside or inside the airport battery limit, and you bring the hose that gets attached to the wing. Everything remains identical.
So it's dropping. And if you, from an economic standpoint, the switch is a lot easier than that's aviation. Outside of aviation, are there other use cases for the CleanJoule SAF in trucking or military ground vehicles? Any other type of operations that you could use it for?
If military buys it, they will use it for everything. We know that, right? But our target has always been aviation focused. So it is kerosene range. Can you drive a truck off of it? I'm sure you can. Can you drive actually a two-stroke motorcycle? You can if you get it fired up with a little bit of gasoline. Like you have to get the temperatures up for running it on kerosene grade hydrocarbons. But I'm not going to unnecessarily make up markets to answer your question in sort of a most appropriate way. Our focus is fully Jet A and Jet A alone because we strongly believe there are electrification solutions to everything that is surface transport.
You're focused, which I give you a little credit for. Some entrepreneurs go all over the map and they want to be Baskin Robbins. They want to have a flavor for everybody, and you know this. You can't scale it. It's not going to work. Okay, so this person wants Oreo. This person wants straw. Okay, geez Louise, we're only doing aviation. If you want to eat aviation, we got that for you.
Exactly.
And in your opinion, what is the future of CleanJoule SAF?
So we are on a journey to continuously get to that commercial scale. So over next 5 years, we will have first commercial scale manufacturing plant producing multi-million gallons in the United States. We have geographical expansion plans. We have partners from Southeast Asia, as you may have seen, Gen Zero, which is the clean tech investment arm of Temasek. They are an investor. So APAC region is huge for us. We are talking to other players in that part of the world. Europe is huge for us. Wizz Air particularly. I sometimes hide from our airlines because their first question is, "Where is my tanker?" I'm like, "It's coming." So. But the idea is to build manufacturing in Europe as well. So we will have at least one manufacturing plant on all three continents in next 10 years.
Diversified, and I think from a risk perspective, we don't know where they're going from an economic standpoint, but we do know from all the economic data, APAC's growing, and APAC is going to be an incredible growth market, as we talked about earlier, especially as India continues to come online and the investment dollars continue to go into that wonderful country. Mukund, as we look to wrap up this insightful conversation today, what would you like our listeners to take away with them?
I would talk to the engineers among them first. Is this is a bit philosophical, not about CleanJoule. If you are looking for doing something, decarbonization is the place. I think it's a massive global challenge. You are more than welcome in aviation as a sub part of it. But for the other audiences, Grayson, I think it's an ecosystem transformation. So don't be short-sighted about anything either you do, or don't be judgmental about others do with time on x-axis. This is a long-term journey with an extremely robust and efficient incumbency that you are about to expand. And if you happen to be not a believer of man-made climate change, look at it as an energy expansion opportunity. See, 100 billion gallon today of Jet A going to 160 billion gallons by mid-century. Petroleum is not going to grow 60%. There is no way. We are a balanced world at 100 million barrels per day, and it will remain to be so around that. And on top of that, when electric cars and electric trucking are going to destroy the gasoline and diesel markets progressively, what are we going to do with kerosene production? Who has the reason to produce that incremental marginal barrel of petroleum? Ask that to yourself. This is societal transformation of a civilization that we are staring into, make your x-axis as large as you can, because that's the way to become relevant. And that x-axis has time on it, as we all know. So do not be short-sighted. Do not be judgmental about if somebody is taking longer. That would be my message. The fuel is coming and we will fly you. That is a foregone conclusion. But how do we change society from here on is kind of the pivotal question.
CleanJoule is developing the future of aviation fuel. Today is tomorrow. Tomorrow is today. The future is CleanJoule. Mukund, thank you so much for coming on SAE Tomorrow Today.
Excellent. Thank you so much, Grayson. It was a lot of fun.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we discuss the role that electrified trailers will play in the scaling of commercial transportation.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.